Hello, thanks for tuning in. Today, we at ON Semiconductor would like to showcase our smart passive sensor technology in a wireless occupant classification application. You may have seen some of our previous videos on smart passive sensors where we show them in a moisture detection scenario. These very same sensors can be harnessed for proximity and pressure sensing capabilities as well. If you would like to see these previous videos on how to better detect moisture in vehicles, please check out our other videos in this playlist. I would like to pose a question. What if your car could identify the difference between a heavy bag of groceries and a human being in the car seat? Then you wouldn't have to worry about that flashing seatbelt light on your whole drive home. You also wouldn't need to place your groceries on the floor of your car or try hanging them from the back of your car seat and risk the bag handles ripping and leaving a mess in your back seat. You also wouldn't need to worry about buying a special contraption to place inside the seatbelt. What if we could have a full system that identifies human occupants as opposed to simply identifying if something is placed in the seat? Also, what if it could detect the occupant's position, size, and the population inside the vehicle with no wires and completely hidden from view? Let's take a look at how the new smart passive sensors from ON Semiconductor can help with all of the above, as well as fixing that annoying seatbelt reminder light. Wireless OCS began just like all technical innovations do. For automobiles, we can look back and see how it all started with safety. In 1966, seatbelts became mandatory for all vehicles. Then front airbags became mandatory in 1999. From then on, safety standards and regulations continued to increase to lead to where we are today with wireless OCS. Today, we can now utilize wireless OCS to determine whether a seat is occupied by a human or non-human, and determine their position in the seat itself. This can be useful to determine where the vehicle's airbag should deploy so as not to injure the passenger. In the case of a small child, the airbag would deploy much lower than it would be for a larger adult. Wireless OCS can also be utilized the same way in vehicle rear seating with removable seats where traditional wired methods fall short. The smart passive sensors from ON Semiconductor are completely wireless and can easily be included inside a removable seat where it is out of reach for the consumer and easily operational when the consumer puts the seat back in place after removing it from the vehicle. And all of this can be brought about with a decreasing cost structure with innovations in wireless capabilities and associated weight as a major focus for innovation. Now, to get into what OCS looks like today, many current solutions utilize active sensing, therefore requiring a power source for each seat to be active at all times that the vehicle is on. Many current solutions are also wired and attach each seat to the vehicle itself. You can see how this causes issues when you would like to remove a back seat for storage purposes. Current solutions also have no way of detecting if a person or an object is occupying the seat and where their position is within the seat. So to innovate and meet the market needs for a truly passive, wireless, and innovative detecting solution, ON Semiconductor brings about our smart passive sensors. The smart passive sensors have the capability for pressure sensing, which is used in this application, as well as moisture detection, temperature detection, and proximity detection, to name a few. On the left of your screen, you can see one of our smart passive sensors in actual size. They are as thin as paper, only a couple inches long, and can be placed on almost any surface that you need. Again, these are completely battery-free wireless sensors that utilize a single chip inside called Magnus for energy harvesting and utilizing the ultra-high frequency RFID protocol for data transfer. Here is a more in-depth schematic of the SPS. You can see that the antenna block on either side controls the wireless RFID communication and energy harvesting. The sensing block, powered by Magnus, is in the middle of the sensor where the moisture, temperature, proximity, and in our case, for this example, the pressure sensing takes place. The antenna block then sends the collected data wirelessly to the module and processing block where the data is interpreted by the sensor reader and analyzed. Now let's look at an automotive example. If we insert the reader into the roof or underneath the carpet of the car here, then place the individual wireless antennas at these locations of the vehicle, then we can determine all of these different measurements that you see here. So these readers do not just measure one thing only, but they can measure all of these different values for an endless amount of applications without having to change out different sensors or measurement methods. This truly is a one-package solution for measurement reading. I would now like to show you some of the specifications for the smart passive sensors. The reader itself is an on-branded ECU which includes an RFID reader IC, 8-bit microcontroller, and a CAN transceiver. AEC Q100 is in process with ASIL qualification targeted, and the unit itself is CISPR 25 Class 3 certified. The antennas are 3 to 6 dBi ultra-high frequency patch antennas. And the whole system is supported by an ecosystem simulator along with antenna placement optimization and open source sample code as well as development kits included. This diagram shows how the sensors can be placed inside the vehicle. First, we have the dielectric sensors embedded inside the seat to determine the occupant's position in the seat. Then we have the reader that can be installed underneath the carpet of the vehicle. Then comes the pressure sensors in each seat bottom and seat rails. All of this is then linked together wirelessly using the antennas installed underneath each seat. With this complete system, you can monitor all the metrics previously stated completely wirelessly and all through the same interface. With the improved detection from multiple sensors interacting through the same system, this leads to achieving a better resolution for airbag control. By combining the pressure and weight sensors, you can provide better safety to consumers through more accurate airbag deployment depending on the size and position of the occupant. And because there is no power requirement for the sensors, they can easily be placed in both movable and removable seating depending on whichever need you have in your application. So to answer our initial question on what if there was a complete automotive system that can correctly identify humans and their positions without any wires? Well, we are excited to bring you our new Smart Passive Sensor Turnkey solution that fulfills all of these needs. Please visit www.onsemi.com and subscribe to our YouTube channel to learn more.